5 cube divided 5 square times 5. What will be the answer? How do you solve it? As per the order of operation, we first solve parentheses, then exponents, then comes multiplication, division, addition, subtraction. So there is no parenthesis here, but there is exponent. So before solving anything, we have to solve exponent. So one way that we solve the exponent, 5 cube will be 125, then divided 5 square is 25, then times 5. Now after that we have multiplication. So will you do the multiplication? It will be 125 divided by 25 times 5 is 125. Then the answer will be 1. But what if you follow Pemdas, which is the same order of operation, just that in this division is written first and then we have multiplication. In that case, we will do the exponent part. So 125 divided 25 times 5. Now 125 divided by 25 is 5, because 25 times 5 is 125. So we will do division first as per Pemdas and then times 5. So 5 times 5 is 25. So in Pemdas, you are getting 1 as the answer, while in Pemdas, you are getting 25 as the answer. Which will be the correct answer? And why two different answers? Now we are getting two different answers because this multiplication division, they have equal priority. We cannot give multiplication any precedence over division or division any precedence over multiplication, because you see, division is nothing but reciprocal action of multiplication, because when you divide 4 divided by 2, it simply means 4 is multiplied to 1 upon 2. Division converts into multiplication and the number after that gets inverted. We write reciprocal of 2, that is 1 upon 2. So it is then reciprocal action. And because of this, we give them equal priority. And to resolve the issue that which action should be done first, we solve them from left to right. Therefore, in Pemdas, although multiplication is written first, but from left to right you see there is division first, so we'll do division first. While in Pemdas, D is already written first, so it's just a coincidence that D is written first and from left to right there is division. So you can follow Pemdas or Pemdas any order and you will get the same result if you follow the left to right rule. So 125 divided by 25 will be 5, then times 5. So 5 times 5 is 25. So 25 is the correct answer. But we were able to solve this because the exponents are small numbers. What if we have bigger exponents and we cannot simply get the product? How do we solve it then? What if you expand the exponent and then try to solve it? So 5 cube is 5 times 5 times 5, then divided by 5 times 5 and then times 5. So we can expand it like this. But if you expand it like this and then you start solving from left to right, then left to right is 5 times 5 25. Then this multiplication, 25 times 5 is 125. Then division, then times 5, then times 5. From left to right again it is division first. So it will be 125 upon 5. But you see, this will not be correct because this expanded part of the exponent, it is not 125 divided by just 5 as we have done here. It will be grouped together like this, and we will have to divide 125 upon 5 times 5, and then it will be times 5. So 5 times 25 is 125, then 5 times 5 is 25, and then 5 times 5 is 25. So you will have to keep in mind that when you expand the exponents, you cannot just write them like this. You will have to keep them in the parentheses, so not to confuse it. Because even if the digits are same, if you don't put this bracket while expanding them, you will get the wrong answer, because it will be then like 125 divided by 5 and then times this 25. Now this method can be useful, expansion method, when we have a bigger exponent. For example, if we have 5 to the power 5 and we don't want to calculate what is 5 to the power 5 and then division 5 to the power 3 and then times 5. What do you do then? Then what we can do, then we can divide this entire 5 to the power 5 by 5 to the power 3. So 5 to the power 5 upon 5 to the power 3. Then times 5. Now here we can use the identities where when a raised to the power m upon a raised to the power n is equal to a raised to the power m minus n. Here m and n are the exponent. When bases are same and they are dividing each other, then we can subtract the exponent. In that case, it will be 5 to the power 5 minus 3, then times 5. 5 to the power 5 minus 3 will be 2, 5 to the power 2, then times 5. So 5 to the power 5 is now easier to calculate. Then it is 25 times 5, 125. Or what we can do, once we have done this expression, then we can expand it. 5 times 5 times 5 times 5 times 5, then upon 5 times 5 times 5. In this way, we have to do less calculations. Cancel the 3 5s, then it is 5 times 5 times 5 is 125. In this way, we can solve when the exponents are bigger. But when you expand it, you will have to keep them in brackets, so not to confuse that they are separate actions, because they are exponents. We solve them together and then use the operations. So here also, when we group them together, it will be 5 times 5 times 5, then divided by this entire 5 times 5 and then times 5. So you can cancel these two and then 5 times 5 is 25. You will get the correct answer. What if all the numbers are in exponent and the base is also a bigger number, such as 9, it is raised to the power 4, then times 9 raised to the power 3 divided by 9 raised to the power 2. In that case, if we go on multiplying 9 times 9 times 9 times 9 and then multiply again it with 9 times 9 times 9, then divided by 9 square, it will take a lot of time. But since we have to solve the exponent part first, but here exponents are a hassle to solve, we move to the next part, that is multiplication division. Now for multiplication division, we have to solve it from left to right. So we will solve it from left to right. We consider 9 to the power 4 as a number. Now 9 to the power 4 times 9 to the power 3. 9 is the base and 4 and 3 are the exponents. So there is an identity. If a to the power m times a to the power n, then it is equal to a raised to the power m plus n. If the bases are same, we can add the exponents. So instead of multiplying 9 4 times and then multiplying it to 9 3 times to itself, we will add the exponent here, 9 to the power 4 plus 3, then divided by 9 to the power 2. Now it is 9 raised to the power 7 divided by 9 raised to the power 2. Now this means 9 to the power 7 upon 9 to the power 2. Again there is an identity. If a to the power m upon a to the power n, then this is equal to a to the power m minus n. So it will be 9 raised to the power 7 minus 2. That is equal to 9 raised to the power 5. Now we can find the value of 9 raised to the power 5. 9 raised to the power 3 is 729. That's easy way to find. And then 729 times 81. We can, that is equal to 59,049. So only this much calculation we had to do instead of doing all the multiplication and then division. So for exponents, when the bases are big or the exponents are big, we treat them as a number, use the identities, solve using the order of operation, and then find the correct answer. How did you solve it? Let me know in the comment section. Thanks for watching.